Hello, my name is Justin Quinn, and I'm a solutions engineer at Logz.io. My day-to-day job involves meeting with prospective Logz.io clients and determining if they're a good fit for the Logz.io solution. Before we hop into the topic for today, just to give a little bit of an overview of Logz.io. So Logz.io is a fully managed observability platform. It's based on open source tools. Being a fully managed SaaS offering allows our clients the ability to ship their data to our solution and not have to manage, monitor, or scale the backend infrastructure that comes with using open source tools. So whether you're sending 5 gigabytes or 5 terabytes of data a day, our solution scales to your needs. So just hopping into the presentation here today. Today we'll be talking about designing an open source observability stack for distributed environments. So modern DevOps environments today consist of many different pieces, such as multi-cloud solutions, containers, and microservices. Many teams are left blind to what's going on in their environments without the right observability into their systems. So what exactly is observability? So isn't observability just another word for monitoring? Is it about collecting logs, metrics, and traces? So one of the definitions that we like here at Logz.io says that observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. So what exactly does that mean? So it means that if we have a system, and that system doesn't necessarily have to be the code that we wrote for an application, it could be something like a car or even our own bodies. We want to know what's going on inside these systems based on the outputs that these systems are giving off externally. So let's take, for an example, our own bodies. So when we are sick, our own bodies give off indicators, things like a high temperature, high blood pressure, or even a headache. When we gather these outputs, we can then conclude that we're sick. So the same thing goes for car. If we see that an engine overheats, we know that there's potentially some type of issue with that car. So the same thing goes with our environments. So we write code, we deploy that code to production, but it doesn't always work the way we expect it. So sometimes there are bugs, errors, and issues with that code. We can't see what the code is doing. So the question is, how well did we instrument that code and build around it the ability to then troubleshoot and figure out what is going on based on the outputs that are being given off? So let's take a look more into what observability consists of. So the typical definition of observability contains 3 aspects. So observability entails collecting logs, metrics, and traces. So the first piece of data that many organizations will collect will be logs. So logs are typically text-based, unstructured data. So reading through logs can be easy on a small scale, but as systems and applications grow, the number of logs will grow as well. So troubleshooting an issue manually and having to go through millions of log messages is not really a feasible task for any engineer. Logs are easy to collect, but they're hard to interpret and understand. The second piece of data that's usually collected will be metrics. So metrics are used for infrastructure monitoring. They can show the health of a server by looking at metrics like CPU utilization, memory usage, or anything like disk space. You can even collect custom metrics directly from your code that show things like the number of errors or the number of sessions or any other numeric value that can show trends over time, which helps in identifying anomalies. Metrics can help in identifying these anomalies over time or any health issues with your infrastructure, but metrics are not going to give you the underlying context as to what's causing the anomaly or health issue. To get that underlying context or the root cause of a CPU spike or memory spike, you then have to go back and look into the logs. So the final piece of observability here, well, the third pillar, I guess you could say, of observability is tracing. So tracing is used by DevOps teams to monitor the performance of their application. Tracing can help identify any bottlenecks that occur throughout a microservice-based application. So typically we see organizations tackle logs and metrics first to identify the availability of their systems, and then they can use tracing to monitor the performance of their applications. So now just going over some common impediments to observability. So the first two that are highlighted in white here are pretty obvious. If I'm not collecting enough information or collecting only information that's not actionable, then I'm not going to be able to troubleshoot that system. The second two bullet points highlighted in yellow are more prevalent in distributed environments. So collecting too much information and being overwhelmed by the noise can make it much harder to identify data that can help figure out the root cause of an issue. Fragmenting access to information, especially in transient environments, can cause issues too. Only getting bits and pieces of data can make it harder to figure out what's actually going on in your environment. So let's take a look at the architecture and how it's changed over time. So we started out with a traditional architecture. So a traditional architecture was a monolithic architecture on a single server. If there was ever an issue, all you had to do was SSH onto that server and tail and grep log files to find out what's causing the issue that you're facing. So that traditional monolithic architecture has since evolved once containers and orchestration was introduced with things like Kubernetes. It made it much more efficient for developers, but it made it more difficult for operations teams to monitor. So distributed production deployments of things like Kubernetes often scale up to hundreds of nodes, pods, and even services. With so many moving pieces, getting to the bottom of an issue in a large distributed system can be quite challenging. Alternatively, in a traditional monolithic environment, one might need to only search through a log or two. But with microservices, you must go through many different logs. And basically, you need to go through those logs to figure out what the issue is. Sifting through logs from so many different services can be time consuming and often not helpful for discovering the true root cause of the issue. These distributed environments are also verbose as well as noisy. So a large amount of the different signal types that we're getting from these distributed environments means extremely high volumes of data. Like I mentioned before, a Kubernetes deployment can be notorious for generating large amounts of data and requiring efficient systems for handling the high volumes of data being sent. So all of this data can then tie up the visibility that users have within a certain environment. So let's take a look at how we can overcome this challenge. So overcoming the challenge into gaining observability into distributed environments can be achieved with some open source tools. So what we can see here from this slide is a Data&I survey that was conducted in 2019. And it stated that 85% of companies use open source tools for monitoring. So you could see listed on the slide here a few different open source tools. So things like front-end visualization tools like Grafana can be used with Prometheus and Elasticsearch to visualize metrics data. Kibana, or the ELK stack, can be used as a log analysis tool. And Jaeger is typically an open source tool used for distributed tracing. Integrations between these open source observability tools can act natively with open source orchestration tools like Kubernetes and Docker. So why is open source the most popular choice here? So there's a few different reasons. So open source tools are accessible. So open source tools like the ones we just looked at are free and available for anyone to use. Engineers are also typically already familiar with these open source tools, which reduces the learning curve. So as an organization, if you hire a new engineer, they're almost immediately able to come in and immediately start using the open source tools that are being used in your environment. Open source tools have a strong community behind them, and they're built to solve developers' problems. The tools are also ever evolving in order to keep up with the challenges that different DevOps teams face on a day-to-day basis. The open source tools that we're looking at are also DevOps native. They integrate well with other open source projects, as well as DevOps workflows. And the final point listed here, open source tools are often cloud native, and they're built for monitoring things like Kubernetes and serverless environments. So now let's take a look at the open source observability toolkit. So we could take a look at how we would ingest logs. So an organization might use something like the ELK stack. For those that aren't familiar with the ELK stack, ELK is just an acronym for Elasticsearch, Logstash, and Kibana. You can also use the beats family, so things like metric beat, file beat, winlog beat to ship that data to the ELK stack. FluentD and FluentBit are also popular open source shippers that are used to ship logs to the ELK stack. The final bullet here under the logs would be Loci. So Loci is a logging solution that is made from the users of Grafana Labs. So this is another tool or an alternative to the ELK stack. For metrics, within the market today, most users for metrics are using a combination of either Prometheus, Graphite, InfluxDB, or Elasticsearch with a front-end visualization tool of Grafana. And we'll go into kind of more on what these tools mean down the line here. And finally, just for tracing. So tracing, Jaeger and Zipkin are usually the most popular. Jaeger was actually a project that was created by engineers at Uber. And both Jaeger and Zipkin support open tracing. So I know we've talked about so far how to gain observability, the three pillars of observability with logs, metrics, and traces. But one thing that people usually leave out of observability is security. So many engineers will focus on just writing the code, and they'll have others focus on security after the code is written. The reason why it's not the same nowadays is because the threats in the security landscape have changed from on-premise monolithic environments to cloud-based environments and microservices. So it's no longer enough to just have a firewall that will protect the perimeter and maybe endpoint protection on your servers. The transient environment and nature of microservices makes security much more difficult. So we see many more organizations transitioning to a DevSecOps type culture, which focuses on building in security throughout the DevOps pipeline instead of just adding in security after the fact. So these teams are utilizing open source security tools, things like Wazoo, Zeek, Suricata, as well as Falco for Kubernetes, and aggregating that data into a centralized place like the ELK stack. Organizations that are using cloud-based environments like AWS might use like GuardDuty and CloudTrail, which are security and auditing tools from AWS. that can then be correlated with those open source network intrusion detection systems that I just mentioned, in order to then identify any type of malicious behavior in their environment. So here we can see just a few snippets from some articles here. So a few examples of security incidents. So any server that is publicly facing will be attacked in a matter of seconds once that server stood up. Like I mentioned before, so Falco is a good open source auditing tool that can be used with Kubernetes environments, because any kind of sensitive information in your log data needs to be secure when that data is then being transmitted to your observability stack. So let's take a look at a production checklist for an observability stack. So your observability stack needs to be resilient and reliable. So you have to be able to send your data to the observability stack and make sure that your data is getting there. Companies these days that have adopted a DevOps culture with cloud and microservices grow quickly. So then being able to scale your observability solution to meet the needs of the growing amount of data that you'll be sending to that observability stack is critical. Performance monitoring and fine tuning. So being able to access your data quickly decreases your mean time to resolution. So being able to scale something like Elasticsearch or Prometheus does typically require a certain bit of expertise. Archiving and backups are important for being able to go back and look at security incidents. And then finally, so security and compliance is important. Like I mentioned before, if we are sending sensitive information to our monitoring tools, we need to make sure that that data is secure, because that's important for compliance reasons as well as for companies' reputations. So let's take a look at a sample production architecture for logging with the ELK stack. So the first thing that's important is being able to collect the data. So here we can see our data sources are coming from Kubernetes, Zeek, Wazoo, and Docker. To ship data from these tools, we can use shippers from the Beats family. So anything like FileBeat, MetricBeat, WinLogBeat. And then once that data is being shipped, you'll then want to be able to queue that data. So queuing your data is important so that you're not putting the load on your system or applying any type of back pressure to a production observability environment, which can then cause that environment to run slow. So basically by queuing that data in Kafka, we're alleviating the load on the Elasticsearch indexes here. Logstash is another important piece because Logstash is a processing tool that is able to go through and parse the data. So parsing the data that you're sending to the ELK stack is important so that you can then search, visualize, and alert on the data that you're sending. Multiple Elasticsearch instances can also be used to search the data. So think of Elasticsearch as like the search engine for your data. And you're able to search the data that is being parsed from Logstash. And then the final piece would be Kibana. So Kibana is the front-end visualization tool that you're able to go through and visualize and search the log data. Within Kibana, you're also able to create dashboards, visualizations, to see any type of trends or anomalies within your log data here. And then finally, replicating the environment is also important. Replicating the environment ensures high availability of your observability logging solution. So let's go into taking a look at a production architecture for metrics-based data with Prometheus and Grafana. So Prometheus can be used to pull metric data. Prometheus uses a pull mechanism, so users are able to control the pulling interval, which is helpful when the servers are busy. Prometheus also has the ability to then push alerts to endpoints, so things like email, PagerDuty. That way, if you create alerts within Prometheus, you can have an alert for, let's say, CPU utilization. When CPU utilization reaches a certain threshold, you can cut an alert and have that alert sent to the endpoint of your choice. You can also use Grafana as a front-end visualization piece for Prometheus. And basically what Grafana allows you to do is visualize that metrics data over time. So you can take a look and see, what's a normal threshold for CPU, disk, or memory over, let's say, like a 12-month period. That way you can identify any seasons potentially that you might ingest more data than not. So the final piece here is just going over a production architecture for tracing with Jaeger. So implementing a tracing solution is ideal for organizations that need their application to perform well. So many users of applications do not want to use an application with high latency. Nowadays, if you open up an application and it takes a while for that application to load, users are no longer going to want to use that application. They'll find an alternative. So Jaeger is a great open source tool that identifies any bottlenecks within the microservices making up that application. It's typically a tool that we see organizations implement once they get to a certain maturity level with their observability stack. So just wrapping up here, overall, the move from monolithic architectures to more distributed environments, cloud-based environments using microservices, it's made gaining observability into your systems complicated. But you're able to use some of these open source tools that we've mentioned to help you achieve better observability into your systems and essentially make your revenue-driven applications run better and perform better. So that's it for today.